So as I mentioned before, that with any effects in Houdini, you need a source. You can't really grow a fruit without a seed. And we're going to follow the same concept here, where we will be talking about on how we can set up a source for our white water points. Right, so what I'm going to do is I'm going to drop down a node called white water source. And I'm going to connect the output of my unpack node here, which is our particles, to the first input of our white water source. And if I visualize this, you will see that Houdini is going to take its time to compute a lot of things. Now, before we jump into the settings of white water source, I do want to talk about how side effects completely revamped and changed the white water system in Houdini 17. Starting Houdini 17, they changed the white water source to be a VDB source. They changed a bunch of options in the .NET, and they also added a lot of control when it comes to the repellents or the erosion of our white water. So we're going to be taking a look at all those in the next couple of videos. But because they made the white water to be a VDB now, the source of the white water is VDB, it's a lot faster to compute than the traditional particle method. So if I middle click on my white water source now, you can see there is a VDB called emit. And you can see there is some volumes on our viewport, heavy volumes. It's almost 5.6 million voxels. So this is the VDB representation of our white water source. If you want to see the points as well, you can go to the visualization tab and say source particles, and Houdini would, again, it would compute and it would show you how it looks in terms of points, how it would look if, there you go. So this is how the points look of our white water, but we don't really need it. We're going to work with the volumes, and that's going to be it. Right, so again, it can be very heavy, so when you're testing it, I would recommend you to go to the volumes tab and put the voxel size really high, so it's not that high res, and the voxel count is down to 109,000 voxels. So now you can freely move in the viewport. Right, so now I need to change a couple of things here. I'm going to start with curvature. I'm going to leave the curvature range to default, but the max velocity angle is essentially an angle relative to the surface normal. So the angle between the velocity of the particle and the surface normal must be lower than this value for white water emission. So obviously increasing this value would give us a lot more white water volumes, right? So if I, let's say, put this to 90, you will see we have a lot more volumes here. So a lot more of the area is going to emit our white water points. Obviously, it's a bit low res. You can see it's all voxely, but we're going to fix that later. Right. The acceleration is going to do the exact same thing as well. The lower these values are, the more it's going to take into account as an emission source. And for this, I'm going to put this, I'm just going to put this to mount. Actually, no, it's low res enough that we can do real-time updates. So put that to 10. Now you can see it's really getting out there. And put that to 20. There you go. So now we have a really dense white water source, and it's going to emit a lot more points. Obviously, these settings are not set in stone. It's very project dependent, and it's dependent on how you want your white water to look. If you really want a dense looking white water simulation, then these settings would work. And finally, in the emission tab, even though it's not going to change much, what I'm going to do is put the speed range to 1 and 2.5. And that would give us very small little bits. So let's say if I put this to default, so I'm going to zoom in here. And if I put this to default, revert to defaults, you will see we will lose some areas here. But putting that speed back to 1 to 2.5, again, it considers a lot more area to emit white water from. 1 to 2.5. There you go. Okay, so now what we can do, we can put this down to a lower value so as to have a lot more resolution on our white water. But what I'm going to do, I'm going to copy particle separation from my ocean source, put this to manual, right, and paste relative. Okay, before I do that, one thing I almost forgot. So right now, if I go to my side view, you can see our white water is touching the floor of the ocean, and I don't really want that. You're not going to be able to see that in your renders. You're not going to be able to basically tell if it's there or not. So what I like to do, instead of emitting those points that are not going to be visible, I would like to delete that source altogether. I don't even want to compute the points. I don't even want to delete them after DOPNet. I want to delete them pre-sim, so my DOP simulation is a little lighter, or relatively lighter. Right, so what I have here is this cliff geometry. I'm going to put this to auto update. So I have this cliff geometry here, and I've done, actually let's call in our cliff geometry out cliff geo. Cool. So we have our cliff geometry here, and it's connected to a bounce up. So hide other objects. So this is a bounce up. So essentially, when I put a bounce up and put that to my cliff geometry, you can see it creates a bounding object around my geometry. And then with the lower padding and the upper padding in X, Y, and Z, I can change the bounce to be looking like this. And then I'm going to say VDB from polygon, so it's a VDB surface. Right, so if I visualize my white water source again, there you go. And if I reference my bound, you can see my bound is sitting right above the ocean floor. So essentially what we want is, okay, any VDB inside this bound, delete it. Cool. So we got without VDB, which is surface. We got another VDB here, which is emit. And what we're going to do, I'm going to put down a VDB combine node and put the required A VDBs to white water source and B VDBs to our box here. And I'm going to VDB combine them. And I'm going to set the operation from copy A to multiply. Done. Any VDB that was inside that box is going to get deleted. And that's what we wanted. Correct? Right. Now, I'm going to say ocean source, copy parameter, white water source, paste relative references to the voxel size. I'm going to put this to manual. Okay. Right, but I found that this setting, this value is way too low. It's way too high res. So I'm going to multiply that to 1.5 and say 0.147. And then I'm going to auto update, and it's going to take its time to compute. Okay, 15 seconds, roughly 15 seconds, but we are up to almost 13 million voxels. And if I go to my side view, you can see that our floor is cut off. Right, and usually, I know a lot of people don't do this, but what I prefer is to save out the source, because it gives it will decrease your simulation times, because it's not going to compute your white water source and this VDB combine every frame. So if you cache that out, it's going to read every frame from the disk, which is great. Right, and then I'm going to say load from disk, but it's not doing it because this is not correct. So I have saved it as $OS in the folder, and that should be reading from the disk. Yes, I think it is, because it's taking its time to compute. There you go. Right. So now we have this white water source that we can call in our DOPNet to emit our white water points from. But before I conclude this chapter, a couple of things. I want to show this flipbook of this white water source, so you can see that these are the areas that we will be emitting our white water from. But white water source is not the only thing that we need to simulate our white water. We also need the surface and the well field isolated, and we're going to do that using a simple blast sub. So this scene is really heavy, and that's why what I'm going to do is I'm going to put this to manual mode, so I don't have to deal with the computing again and again. Right, I'm going to go out white water source. Right, so now, if you remember, when we set up our DOP import field, we saved out surface and the well field as well. And that's what we need. We need to isolate those as well. And why we need to isolate those, we're going to talk about when we set up our DOPNet. Right, so again, my unpack node, and I'm gonna drop down a blast sub just to make the scene a little cleaner here. Right, and that should be cool. You can press Shift S, by the way, to make our lines a bit more pleasant to look at. And then what I'm going to say is I'm going to go to the first frame, and I'm reading it from the cache. Yes, I am. Auto update, and right now obviously it's going to go ahead and blast everything. If I middle click onto my unpack node, I have a surface and a vel. Cool. That's what I want. I want at name equals surface, right? And at name equals vel. And I want these two to be not deleted, but everything else deleted. So I'm going to say delete non-selected. And if I middle click on here, you can see that our particles are gone, but our surface and vel field are there. And vel is set to 000 because we're on first frame and there is no activity on the first frame. So if you scrub through the timeline, the vel field would have voxel numbers here. You can also, instead of typing it, you can say at surface here and at vel here, and it's going to do the exact same thing. And again, I would wholeheartedly recommend you to save this out, because it's going to be easier on your sim times. Load from the disk, null, and I'm going to say out white water fields. Cool. So now let's take a look on how we can set up a .NET.